who's got the, all right, here we are. It is week 3. It is the where clause week. We're going to talk about the where clause and how where works. Although we kind of talked about how where worked last week. We're talking more about where and the ways we can modify where and to filter data. It's all about data filtration. Before we begin, does anyone have any questions from last week's assignment, specific questions about this week's assignment, questions about anything in general that I can answer?
I did have one.
Sure.
I guess I'm just still a little bit unclear about the command line tool.
Okay.
And when it's good to use it.
So you're going to get the gospel according to Brother Stevic right now when it comes to the command line interface tool. Okay. The command line interface tool is a very powerful tool that allows you to granularly control everything going behind the scenes of a database. And it is an awesome way to show off. If you want people to think you're like really awesome, use the CLI. If you want people to think your job is 30 times harder than it really is, use the CLI. When I first became a DBA, I was in Microsoft SQL Server, but I would open up a command prompt. And I don't know if anyone's as old as me here, but when I was first dealing with computers, the screen was black and the letters were green, and that was it. There was no pictures, there was no graphics. That was it. There were CRT tubes, and that's how they worked. So my first paying gig as a DBA, I came in, I turned the screen black, I turned the words green, and that's how I coded. And everyone's like, wow, that's really hard. I'm like, you have no idea how hard this is. And it's really not. It's not hard at all. In my professional opinion, and having been a DBA for 23 years now, there is no good reason to ever use the CLI unless you are doing some hardcore coding that requires you to like control which specific processor on your chip the code is using. So it's cool to know that it's there. If you're a hacker, it's incredibly valuable in hacking into the back end of a server. But for the most part, not really necessary. Just use the workbench. You can use something called Toad. You can use my workspace. There's a bunch of other things. Everything you can do in the CLI, you can do from here. I'm pointing to my screen. You think I'm pointing at you, but I'm pointing at my screen. So that's it. So that's what it is. I mean, it's some people like using it. For another example, in the world of so sometimes cybersecurity people think that taking away a tool bench makes a server more secure. And when you're running on a Linux backend or Windows Core backend, there is no GUI interface. So you've got no choice but to use the CLI or the command prompt interface. So it's good to know how it works. But 99% of the time in field, in job, you're never going to use it. Okay. So that's the gospel. I mean, there are some people who swear by it. Like, woo, look at you. Green words on the screen. Good job. Anyway, does that answer your question about the CLI?
Yes, it does. I was just a lot more comfortable with using Workbench, but the textbook talks about it a lot. So,
and that's the only time they'll ever talk about it. It will never talk about it again. In that first chapter, they'll talk about it there, and then that's it. See you, bye. All right. Any other questions before we go to week 1, week 2? We're in week 3. Anything? Any lingering doubts, concerns?
Can I kind of piggyback on his last?
What's that?
Can I piggyback on his last question?
Sure, go ahead.
How do you, because I was just seeing if I could do this on the CLI, because like, how obviously MySQL, you can click on the database and see what all the tables are. So is there a way to run a command to say where it'll show you, like, for instance, the Sequila database this is all the tables that are included in this database?
Yeah,
hang on. CLI?
One table, 1 second. See, this is where, so I don't know if y'all watched last week's or not. you can do it's select star from table name. I think that's what it is. But it just, so what happens is when you so let's talk about how the Oracle database is. There are tables in there, they're called metadata tables or system tables that hold this information, and you can select from them. So I think it's table names. I have to remember. See, so I think last week's video I was explaining this. By day, I'm a Microsoft SQL Server developer. Actually, I'm not anymore. Now I'm I am the database as a service engineer. That's my new cool title. But I live in both worlds. So there are tables behind the scenes that if you do select start from table name, it'll show you all the tables. I think that's in I think in Oracle it's like tables namespace or something like that. But there is a way to do it, and there's a table that connects you to the columns that are in the table. So you have to write, you join the two tables together, and you can get that information. If you do a quick Google search on it, it'll give you the information. That's what it is. But there is a way. And like you said, everything's just sitting over here, so you don't need to write the query for it. But and I'll admit that it was telling Bryce that now with cybersecurity being like really, really weird about things, you might find yourself in a position where you are on a system where you don't have the GUI interface anymore, and they're not allowing it because it's not secure. I'll tell you a secret. Database engines are secure against pretty much anything. It's the OSs that are the problem. I was with one company, and there was they complained all the SQL servers had been hacked. And what had happened was they hacked into the OS, and they couldn't get into the SQL databases because they were secure. The OSs are open for anyone can get in, but the databases aren't. So, but yeah, so it's select start from table name, table underbar name. But yeah, just Google searching, you can find it all. But like I said, they talk about it's funny with this. They talk about it in the first chapter, and then they never bring it up again for the rest of the course. Anyway, any other questions before we start talking about week 3? Because I'm gonna start talking about the final project first, kind of go in more depth on that one. Then I'll go into what to expect in the lesson. We'll write some code. I'll answer some questions. See if anyone's got anything. No, we're week 1, 2. Everyone's good on week 1 and 2. Everyone got the stuff turned in. The papers are good. The papers are boring. I get it. Now, okay, so let's talk about the final project. This is the big thing here. I talk about it in week 3. It's not due until week 13. So it's due in 10 weeks. And I bring it up now because if you're going to do it right, it takes about 10 weeks to do. Okay. This is not what here's one. Okay. So the final project asks you to design a complete and thorough backend for an application that you design. It doesn't have to be a full, we're not talking like a full-blown application. It could be a section of an application. Like if you're going to do, like the Sakilla database is for a video rental store. Okay. So if you were going to do a video rental store, you would do, I'm going to write the part of the database that just catalogs and displays all of the videos that are here, all the videos that we rent/sell. Okay. So you'd write those databases, you'd create those databases, a database that does that with all the tables. And it has to be a minimum, a minimum between 10 and 12 tables have to be in your schema. Okay. Now, trust me on this, getting to 12 tables is not hard. Because you've got a lot, you'll start doing joining tables and all these little tables. So once you have your idea of what you want to do, in the past, a couple students have done bookstores. One student did a database to catalog his comic book collection. One student did, last semester, a student did an application to schedule their child's time. So what they were doing, where, when, how, who, with, something like that. One person did a application where it was for like a school district's bus drivers to see who drove what bus, when it was driven, what students were on it, things along those lines, repair logs. So pick something, okay? Once you've got that done, you need to start saying, okay, you kind of got to design which aspect of the application you want to do, what page you want to do, what part of it is. So like if you're going to do like a comic book collection, and you want to say, okay, I'm going to do the page where you input your you put in what you're looking for, and it shows you, I'm going to see all my comic books by DC, I want to see all my comic books by Marvel, and things like that. So you kind of like, and one of the things you have to show me is you have to show me like a mock-up of the UI. It can be drawn in crayon for all I care. I don't care about that as much as I do the back end stuff, right? I just want to know you understand how the front end feeds the back end. Am I making sense so far, everyone? We got a round of nods. All right. Okay. Sure, go ahead.
So question. So you're saying, so just how the data from the back end, how it's supposed to feed to X or Y window? Is that what you look for? Just at the very minimum? Okay.
Yep. So yeah. So like if you're doing the comic book application, here's this page where you can search your collection to see what you have, and then you show me what it's going to look like. Then on the back end, when you design the database, you got to say, okay, here's how the table structure would look. I would have a titles table, I would have a publisher table, and so on and so forth around the bend, right? That's called an ERD. ERD stands for Entity Relationship Design or Diagram, Entity Relationship Diagram. There is a way, and I'll show you this probably next week or week after, in Workbench. If you can create the ERD in there and then hit a button, it'll generate the code for you. So you want to do that. That's a very important thing, okay? Because one of the things you need to turn into me is a picture of the ERD, but also the code to create it, okay? Because what's going to happen is how I grade this is I run the code you give me to see if it works. And if it does what you said it's going to do, okay? So you got to create the ERD, all the indexes, the relationship models, and the foreign key constraints, and all this stuff got to be there. And you generate that script, okay? And then you've got to do what's called CRUD commands. And it is the most tragic acronym in all of the database world. But the CRUD commands are your create statements, which is all your tables, your read statements, which are your select statements, and your update and deletes. So what you have to do once the ERD is designed, you have to populate the tables with data. So if you're going to do the comic book company, you need to put at least 5 to 10 lines of data in each table. So if you're counting code, we're not going to count the generation of the tables because that's going to be all click of a button automatically happen. So if you have 12 tables, 5 insert lines per table, you're looking at 60 lines of code to insert the data. Okay, not bad, not horrible. Once you've got that done, you need to create and write the script files for test cases. For example, a test case is when you as a developer sit down, you're creating this database, and you think to yourself, I'm an end user. How do I want this data presented to me? What would I want to see? Okay. Let's jump to the let's go to the video rental database, right? So you're designing a video rental database. You've got you've got the tables in there. You've got like you've got the fake rental data. So people rented when. So you say to yourself, as an employee of the company, or as an employee of the company, or as a manager of the company, I want to know what genre of movie is most popular in the month of May. Okay, and if we look at the Sakilla database, we've got a genre table. Where is it? No, it's here. It used to be here. It's not a genre here. It's category. So category. It's category in this case, right? So I've got category and I've got a rental table. So I can, and so in these all these tables, you look at the connect together. So I could write a query that said, in the month of March, what was the most rented category of video? And I would show that query. So I would write that query and I would show you. I would say, in the month of March, what is the least rented category of video? And I'd get that too. I would want to know how many people rent videos on their birthday? Okay. And these have, these have, if you're a manager for a company, these have, I want to know if for some reason rom-coms are not rented in March, I do a sale on them in March. Rent one, get one free in the month of March. I want to generate sales. That's what data is used for. It's to generate, give information to people so they can do better with what they've got, right? As a customer, what would I want to see? I want to see every movie rated PG that has a specific actor in it. I want to see every cartoon that is science fiction that has a rabbit in it, okay? And these are all queries that we can write off of this database, okay? So when you're doing your test cases, you're basically thinking to yourself, I, as an owner of this company, or I, as a customer of this company, how would I want this data presented to make a difference in my life? Does that make sense? Okay, and you need to write like 10 of those. So what you're going to do is you're going to say, this query will tell me how many people rented romantic comedies in April, and it'll show me, this query is going to show me which store did the best business in the month of December. Okay, this query will show me which employee upsold the most popcorn. Okay, so that's what that comes down to. That's what you want for that. Right. And then, so you're going to create the ERD. You're going to show that to me with a minimum of 10 to 12 tables. It doesn't have to be 12 tables. 10 to 12 is fine. I don't want tables that don't make a difference. Your CRUD statements. I want a mock-up of the UI, just like drawn, whatever. One student actually went through the hassle like writing one on a web page. If you do that, awesome. I can't give more than 180 points for this. So, you do what you need to do, but I'm a back end guy. I can't make things pretty. I can make things functional. I'm awesome at that. So front ends, I just, oh, that's nice. And the test cases for the script files that work. So I can show you and tell me why you wrote it, what it's supposed to do, and then I'll run it to make sure that it does what you say it's going to do. And the last thing you need to do is either prepare a PowerPoint presentation or a video and just explain it to me and walk me through it. That's it. That's the final project. It does take a while to do. Most students take about a week or two to zero in on a topic. And then it takes 3 to 4 weeks to, mostly because you guys have other things to do with your lives, 3 to 4 weeks to get the table structure down. And then right around week 5 or 6, you'll see these meetings will start turning into show me what you got, and I'll walk you through it to see where you can fix your tables. And then after that, it's just being a code monkey and filling it, right in the codes for the CRUD, right in the code for the things, and you usually finish right around 10 or 12. Week 10 or 12. 13's the drop dead date. I can't take it after that because I won't get it graded in time. It takes me about 45 minutes or so to grade each project. So does everyone understand the intent, the project? Are there any questions on the project? Is anyone interested in doing the project?
I'm interested in doing project.
Cool. It is either or. You can either do the project or the final exam. You can spend the entire next 10 weeks doing the project, and on week 13 going, I'm not going to get it done to do the final exam. I'm not going to get mad at you. Do what you need to do. The project was added onto this course about 2.5 years ago because the title of this course is Database Administration and Design. And up until that point, there was nothing we did about designing a database. So we threw this in. They would ask you about normalization of data. They would ask you all about that stuff, but we would never actually give it any practical use for you. And this is your practical use. We'll talk about normalization of the data. We'll talk about all other stuff as I see the projects start to emerge. If you choose to do the project, Go over here. So this is your weekly paper. You've had a profitable second week at your new company. You now know how to use structured query language mechanics to write queries. Yada, 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 yada. Okay. If you are doing the project, you don't write this. If you're doing the project, you give me a quick 2 to 3 paragraphs saying, this is what I did this week on my project. So I can keep track of it and help you online. This is your communication to me saying, hey, I don't understand what's going on here. What's going on with this? And I'll be able to help you. I'll usually will respond in videos and walk you through whatever you're talking about, or I'll bring it up the next Wednesday. Okay. So that is a nice side effect of the project. You suddenly don't have to write these case studies about what your boss asked you to do. So that's bonus.
Okay, so so like if we like for the week, hey, I made, you know, this and this and this table, and we're fleshing out or doing a join or whatnot. That would be the things that we'd write on and said, hey, here's exactly what we built out. This is the purpose behind it, right?
Yeah, like week 8. This week I was having trouble connecting these 2 tables. I didn't see the natural flow of the data. I finally figured it out. So I put a join table in there, and here's the way the data is flowing now. So now I figured that out. So now that was my last piece in place. Now the ERD is done. Now I'm starting to look at this. And then like week 9 is like, okay, I started writing the CRUD statements. I was having problems because of the foreign keys. I realized I had dropped the foreign keys before I put the data in, yada, 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 yada. Week 10 is like, okay, I'm on to the test cases. So I'm thinking of this and this. I'm not really sure. And you'll like ask a question like, hey, how would I write this query? Because I'll have if you're doing this project, I've probably seen your ERD. And you'll say, hey, I'm really having trouble figuring out this query. I wanted to do this, this, and this. And then I'll read that and I'll respond back to you saying, here, try this. And kind of show you the way to do that. Or I'll text you, I'll give you a comment saying, hey, I see where you're going with that. Why don't you meet me on Wednesday night at the thing? I think it'd be great for everyone to see this, and then go through and I'll show you the query how to do it. Right. So that's kind of what it is. I need to know what your progress is. Like it'll like weeks 3, 4, like, you know, I'm really thinking about doing something for a babysitting service because my wife is over the young women's presidency, and they do this babysitting thing, and they want to keep track of who's doing what and blah blah blah. You know, and just kind of it helps this. I know when it's sad to admit this, but I will sometimes design a database for fun. I'll get in my head that I want to do something. I'll kind of see how it works out. I'll start drawing this. I had a good friend in high school who would like do calculus for fun at a restaurant on napkins. And I'm like, you're weird, man. And now I'm like, I do databases for fun, and that's pretty weird too. You know, how would this table work together? And just kind of draw it out and stuff like that, you know. But yeah, so that's the final project. I think it's good. I think it's a real nice way to do it. It's a nice capstone to the year, semester rather. And I'll tell you, if you've worked in another class on a project, like if you're in a coding class and you did a front end for the project, you've already got the front end designed and haven't made a back end yet, feel free to use what you did in another class, as long as you're designing the back end here. Okay, because I know a lot of people like take other coding classes. You're taking Java or C# or something. If you've got a beautiful front end that you love, let's make the back end for it. I think that's totally fine. Okay. Any questions on the final project? All right. Let's talk about this week's assignment. Let's make this bigger. Okay. So last week, I took you through the basic steps of a SQL query. Select from where. Where is the filtering option? Okay. Hang on 1 second. Let me get okay, so let me bring this up here. So last week, there was a question in the week in one of the discussion boards, what the date function does. By the way, I'm gonna show this real quick. So here's the way that if I do this, right, this theoretically should work. Okay, that's the time right now. this very second, literally to the second. But if I don't want all this other stuff, if I just want the actual date, I can do this. Okay. And the date function, when it's run, will just give me the date. That's all it does. It's real simple. There's one for month, there's one for day, there's one for year. And if I didn't want date, what if I just want the time? Because, you know, that's who I am. I do time. And that works too. Just gives me the time. Okay. Sometimes these queries are literally what they look like they are. What's the date? Here it is. Select now. Okay. There's now. Okay. So there's that. So select. Let's go. Columns. Let's go first name. I remember this last week. This is really why we don't use the CLI, because I don't have to do a lot of typing. I just do this. I just drag and drop things over, right? And then I want to do.
Come on, you're making it easier for us.
I know, right?
I thought we're all supposed to suffer in these classes.
I don't like doing that. It's boring suffering. Let me say, I've been doing this for 20 some odd years, and I've gotten very lazy in the things that I do. If I find shortcuts, I will spread the word on them, because it's just really good to know shortcuts. Because then you get your job done super fast, particularly if the people you work with don't know about your shortcuts, and you say, like, if they think someone's going to take like a day to do, and because you know the shortcuts and it works and you can get it done in a half a day, you look like a miracle worker. And that's really important, you know. You got to keep them guessing. So select, let's see, first name, last name, and let me grab film name. Give me my title. Yep. Okay. Now, what I'm about to do here is going to actually include information from weeks 5, 6, and 7, because I can't really show a good filter without getting a join in here. So I'm going to join some tables together. I'm not going to go into a deep dive on how joining works, but I'm just going to do some joins here. Okay. I'm going to do inner join. I got to add one more thing. So I'm going to do inner join here. Inner join. I'm going to do from actor. Now, what I explained this in the video last week, but I'm explaining again this week. So I'm going to do actor, and I'm going to put the letter A there. That means from now on, if it sees the letter A by itself, it's going to think I'm talking about the actor table. I'm aliasing the table. I'm giving it a shortcut name, because I need to put that shortcut name in front of whatever column is in that table, so that the engine doesn't freak out. Inner join actor for inner join. Oh no, hang on a second. I gotta. Okay, we're gonna change something here. 1 second. I gotta. Where is my headset's about to die. That's why I'm looking around for the charging cord for it. So what I'm going to do is.
So if you didn't make the alias in there, would it go ahead and try to search everything that had a first name and last name?
So what would, yes, that's a great question. So what would happen is this, like if I was joining film and film table and all these other things that that did not have matching column names, it wouldn't care. It would go, that's fine. I know first name is from the actor table because film and film actor doesn't have first name in it. But if I tried to join the actor table and the customer table, and I didn't specify which table I was getting from, it would it should give me an error that says ambiguous column name. Okay, so that's what it is. The reason I do it, even though I don't necessarily have to for the engine's sake, I like writing code that people who come after me will understand. This way, if I do it this way, they'll know I mean, common sense should say title comes from film, but common sense isn't as common as it should be. So I want to make sure that everyone sees what it is. So by looking, they'll just know, right? I just want them to be a good guide for it. So I'm going to interjoin. I want to join the actor table with the film table. And the problem with doing that is I have no columns between the two tables that I can compare and get a valid comparison from. So I have a table called film actor, which happens to have the actor ID and the film ID in it. So I can compare it there. So I'm going to interjoin the film actor table and call it FA. And I'm going to say on, I want you to join on this column, FA dot actor ID. And where it equals that. And then I'm going to issue another interjoin. And and later on in the class, I'm going to explain how this works more in depth. But right now, I'm just saying, take these three tables, push them together, and give me the information that I want out of them. So it shows me what it is, because I can't. This database isn't built to show me what actors are in what movies. So we've got to do this, right? Join more film as F, and we'll put the F up here next to title. Boom. And then I'm just going to take this and change that to film ID.
So Brother Stevic?
Yep.
So what I'm gathering as I'm watching you here is, despite what the books say, you don't need to put the word as in between your alias and your table reference.
So, funny story. You don't have to. And what happens is this. There are some, so we're using MySQL, right? And MySQL is a happy little database system. It's called an RMDBS, okay? Relational Model Database System. And then there's MySQL, there's Oracle, there's Postgres, there's MongoDB, there's MariaDB, there's Microsoft SQL Server, and there's about 3,000 other proprietary RMDBS systems in the world, right? All of them will understand what that means. About half of them will just throw an error if you do that. Right? So I always don't put that there because and the error it gives is like, it doesn't make any sense. It's like check your back door. You know, it's like sometimes Microsoft will throw these errors, or rather, database systems will throw these errors that have nothing to do with what the problem is. I think last week there was one that was like, error 1695. And you're like, what is error 1695? It didn't say it. What it said was object already exists in the database. It could have said that, but it didn't. And when you Googled the number, it showed you that was the problem. So the book will say, yes, you have to do this because there are some. So also keep in mind, MySQL is open source and people can mess with it. So some versions of MySQL will allow the as, some won't allow the as. Depends on which one you're using. All of them except no as.
Okay, thank you.
Mm-hmm. So now if I run this, it should work, and it does, and it gives me the person's name and the movie they've been in. Okay. Now, I want to put a where clause in here because I only want to know where f.rating f.rating equals PG. And I will run this. And they'll just show me what the rating are. Now look, whatever the where is, it doesn't have to be in the select clause. It can be whatever. Okay. But I'm now filtering this down. I just want to know where the PG movies are. Okay. There is a command called in. Let me put the rating up here so we can play around with this a little bit. F dot rating. And down here, I'm going to say where rating in. And do this. And then do this. And leave it at that. All right. So I'll run this. And what this is now saying is, show me where the rating is in these, is within the two brackets. And I can enumerate whatever I want there. Okay.
So is that like a string lookup, like these specific characters look up anything that matches that? Is that
Yep.
correct?
It looks in here and it says anything in quotes. It looks for anything with PG. It looks for anything with G. And it shows those two. Okay. So you see that the PGB. Okay. I can do this and go have fun and go not in. And that'll do the exact opposite. Okay. So let me do this. Let me write a quick query here. Select rating. Something just really weird and arbitrary from film. Where title, like, do quote. This is where I get in trouble. I'm gonna just play around and have some fun with this, and it'll probably not work. %, underscore, R, underscore, %, close quote. Okay, so let me get the name here too, just so you did. So boom. That one came out right. Okay, I didn't do it right. That's fine. I'll get the right code. When you do the underscore here, it should I didn't do this right. It said show me anything that has an R in it. Just with anything else, it just has an R somewhere in it. I tried to make it the R the third letter, but I didn't do it right. That's what I get for playing around. Anyway, so I just want something that has an R in it. Okay, so show me that. So do that. Okay. And now I need to see if this command works here. It does. Let's see. Okay, so what the distinct command does, if this isn't here, and this is nowhere in your book, this is just me adding stuff because when I riff on code like this, I just add the commands in. If I run this, it shows me like G, PG, all this stuff, right? What if I just want to see, just show me what great ratings there are. I don't care about anything else. So I throw distinct in here. And instead of returning, let's see, what is it, 701 rows here, right? It's just going to return whatever is. Okay. Try Q. Nope, everything's there. Okay. Let's see. Let's do %. Underscore W. %. This will give me all of them. That way, PG13G R, no, they're all there. I'm trying to get one that doesn't give me all of them. I will. Oh well. That's fine. So we did in and not in. Okay, so and we did like. So like tells you is like gives you like something.
Can anyone else hear him?
Can you hear me now?
No. Nope,
Can you hear me
there
now?
you are.
Oh,
Yeah, I
I
can hear you
I
now.
muted myself by accident. Sorry. Anyway.
Okay.
Um. Okay, so that's fine. So we got in and not in. Any and some. So any and all. How do I explain any and all real quickly? Okay, I do this way. Let me do a quick this here. Select star from film. I want to take a look at something. Okay, so rental rate. So let me do where F rating is G and rental rate equals $2.99. Okay. So if I run this, I'm going to get 342 rows. Okay. And if I put my rental rate here, if I add rental rate, oh, notice I didn't put the F by rental rate because it only exists in the one place. Rental rate. Okay. From this, it's going to show me everything that's G and it's also $2.99. If I change this to or, now it's going to show me everything that's G or that's $2.99. Okay. So any and all do the same. Any and all. So there's any and there's all. I don't have any queries offhand to demo this, but I'll put some in the notes when I release the video tomorrow. I'll put some code specifically that use these two commands. So any basically says it does what or does. So if I say select, and it works with a subquery. So if I did, let me see where. That's why I was trying to get the subquery to work, and it wasn't going to work. Select rental rates from film where rate between 3 and 5. Oh, would help if I spelled between, right? Nope, still don't like it. Help you spell and right. I told you I make a lot of spelling mistakes when I write code. There we are. Okay, it's just $4.99 and 6. Okay, so where rental rates let me do something over here. Well, I'm taking a second to check something. Everyone follow me? Everyone got this? Everyone doing okay? With what I'm talking about here?
Yep.
Okay. Where rental rates, what happened there? Where rental rates equal any, and this here, pick up one there and there. Okay. Oh. It didn't like those. Okay. So I got 1,000, returned everything. So all. Okay. So what I'm going to, so that's basically how, that's the syntax for it. I'll curate you guys some nice code that you'll look at and you'll understand exactly how it works. But basically, any and all are the same as and or. Okay. Any is the or, all is the and, but it does the same thing. I just have to write the query in the right way, and I don't have anything up my sleeve right now that I can that will do exactly what I wanted to do. And I'll do the same thing with some. Some is between the two. So let's see, we've covered in, not in, like, between. And then we've got the standard we're doing the where clause. We've got the standard operators, greater than, less than, not equal to, equal, not equal. Anyone know the difference between this not equal and this not equal?
Oh, man, that was going to be my question.
So it depends on the system you're using, okay? This not equal is an inequality in numbers. This inequality is an inequality in text. Okay. That one will almost always work for numbers or text because it sees not equal and it does that. This, depending on the system you're using, may not work for numbers. It will always work for text, but it may not work for numbers.
I was going to say the greater than equal, the double, the little pointy ends.
Mhm.
That was the one they're teaching us in my Microsoft SQL class.
Yep. Yep, that's the one. That one works. This one works in Microsoft SQL Server as well. That's the fancier one. So you'll find like a lot of coding. This was the one that was around from Microsoft SQL Server 2000, about 2005, and then they deprecated it and they just went to this one. But this one still works. But yeah, so this is just an inequality.
Thank you.
All right, less than, equal, not equal to. I think that's all the operators. Between, in, not in. So they also want me to talk about nulls. I'm not going to write queries with nulls. I'm just going to talk about what nulls are. So does anyone know what a null is? Null variable.
No value.
Nobody.
So it literally has no value. It's not a space because a space is a value. Because it's got to have an ASCII value. Space is an ASCII value. It is an empty. There's nothing in there at all. Depending on the system that you use, if you try to write an equality statement in a column with a null, you will get incorrect values, especially in comparison operators. So it is my rule of thumb is to never have nulls in any column that you are ever going to use to write a query off of. And really, I mean, you should nulls are no data, and that's, you know, that's not good if you're doing a database engineer. You know, you want the data there. There are some cases where nulls will work, like if you have a description or something where not everything's going to have it, right? But if you're going to use that to compare, like you should never use columns with nulls in any kind of join. It will never yield the right results. So I don't have any queries that I build off of that, but just know it's bad juju to have nulls in columns unless there's a very good reason for it and it's planned for, and you're never going to write a comparison operator off of it. Okay. Okay, I think that covers everything I wanted to cover tonight. Like I said, I owe you guys some better code for all, any, and some, and I will get that to you when I post it. So when I post the video, I will add, I'll put the code in there and put those there, so you can run off Sakilla and see how it works. and you can play with it there. Are there any other coding questions you have that I can provide the code for you in the notes of the day? Okay. Keep in mind also, like I said, I went through joins. We will do a much deeper explanation of joins week after next. I think it's week 5. I'm reasonably sure it's week 5 that we start talking seriously about how joins work, and I break out my Venn diagrams and talk about all that other stuff and sort of show you the ERDs and how it connects. But like I was saying, it's through these joins here. Where'd it go? It's through joining the tables like this that we're really going to get the data, because the most important thing about a database, I don't really talk about this last week. Does anyone understand what normalization of data is? Everyone know what I mean when I say normalization of data, what that means?
It's been a while since my last class, but is it trying to keep copies of data, multiple copies of data, trying to keep it as low as possible? Is that right?
Sure. Yeah. That's right. That's the second rule of normalization. The first rule of normalization is that a table only has data that is pertinent to that table's title. So for example, the actor table, right? I would only have columns or data in this table that are pertinent and would only go back to this actor, right? Like I'd have name, first name, last name, birth date, because that would only be his, right? I wouldn't necessarily have like astrological sign, because that would only describe him. There'd be other people or her. Other people would have that one. So I don't want anything that won't directly just describe and be unique to that person. Does that make sense? And the reason, but I need to have that real clear data that in a table, so that nothing will be duplicated, because that's rule number 2, no duplicate data. And when I say no duplicate data, I mean no duplicate data in the actual table, like the actor table, and nothing that I find in the actor table should exist anywhere else in the database. Okay, so I never want to see a table with actor first name and last name anywhere else, because that's duplicate data. And why do you think duplicate data is so bad? I mean, does it really hurt anybody? Is it messing things up?
Not necessarily.
Okay, Aaron, who is? I saw Aaron. Who else answered? Patrick, was that you?
Yeah,
Okay.
yeah, that's me.
Aaron, you first, and Patrick, you go. So, Aaron, why is duplicate data a bad thing?
Because if you have it in multiple tables, it might get updated in one table and not in another, and then all of a sudden your data integrity is shot.
Yep, absolutely. So if I have multiple tables, someone might not know there's 2 actor tables and updated in one and not in the other, and my data integrity is gone. We refer to those as dirty reads. We do not want dirty reads. Patrick, do you have another one or
I forgot. Sorry.
Okay, no, let's go. So there's two other reasons why. Well, the other reason why is if I've got 2 tables that have the same thing, and someone, let's go to the chat bubble here. Just pop up. Yeah, I was kind of going for that. Aaron, I like I said, when I code on my own, it gets a little bubbled. So what was I saying? If I've got 2 actor table and coder number 1 knows about one table and coder number 2 knows about the other table, but they don't know about both of them, I have people writing code off of different tables, and if I drop one because I see duplicate data, it breaks everything. It breaks half the thing, right? The other reason why, and for me, this is the bigger reason, and when we talk about data types, this is going to come up again. Data has a size. Every row of data has a size, and that size has to be stored on your hard drive. And if you have duplicate data, you're inflating your database bigger than it needs to be, and you're causing problems with your indexes because the data are duplicate and they're getting all screwed up, and B, you're using unnecessary hard drive space, which comes at a premium. I don't know if you guys, anyone here like work in field and data and servers and stuff like that? Okay, Hard drive space is ridiculously expensive at this point because everything's SSD, everything's in terabytes, supply line, blah, blah, blah. But like, you know, a terabyte in where I work now, a terabyte is equated to like something like $150. And that doesn't seem right because you can go over to the Best Buy and grab a terabyte drive for like $90, right? But it's different when you're talking about structures of data in data centers because these drives are high performance, they're SSDs, they're, you know, manufactured in such a way that they've got longevity to them, so they come at a higher rate. I can't buy an $80 terabyte hard drive for my servers at work. Okay. Which I had explained to me because I'm like, that's ridiculous. I'll just go buy a terabyte drive at work. You're only going to cost me like, tell me I need a terabyte for $150. I'll go get it for like $60 at Best Buy. So when you have redundant data, you're taking up drive space that doesn't need to be done, doesn't need to be used, right? So that's the other thing. And when we talk about data types, and we'll get into that at some point in time, choosing the right data type is also that if you use an int, so if you use like a varchar 45, if you use a char 45 instead of a char 2, that means every column, every row is going to take 45 bits, and these tables can run into the hundreds of thousands of rows. So you're using like terabytes of space that don't need to be used. Does that make sense? So when you're as one of the things as a DBA that really kind of falls in the cracks when you're talking to people about it is you control how much space the database will actually end up using. Right. So, and here's an example. So there's a data type called int, and there's a data type called a big int, and an int goes up to 2.5 billion or something like that. That's the top, and I think it's so it's a tiny int is 2. I want to say an int is 8-bit and a big int is 16-bit. I might be wrong on that, but let's just use those numbers for that sake, right? If I use, and let's say a tiny int is 2. So if I use an int where a tiny int would suffice, I'm using 4 times the amount of the space that I need, right? So if I have a row, if I have a column in a row and I call it int, and it should be tiny int, and I have 8 million rows in that table, I'm using 8 million bits, which comes out to, I forget what it is in bytes, but it's 8 bits to a byte, so it's a million bytes. And then I'm using like almost like a terabyte of excess space because I put the wrong data type in there. And a terabyte's going for like $150, right? So that's one way that it causes a problem, right? If you go the way you use a small one, a big one, you should use a small one. You're filling your database using more space than you. Now, a company I worked for, they had a table that they used their ID column, they used int, because never in their minds did they think they would exceed 2.5 billion rows. They sorry, 2.5 million, 2.5 million rows. They did in year 10. They exceeded, they were on the verge of 2.5 million rows in that table. So they had to change int to big int. So they went from 8-bit to 16-bit. They literally doubled the size of that table with that one column. Guess how long it took for that action? When they you can go ahead and change it with data, and you can just say, you know, alter table, change int to big int. We had 2.5-ish million rows. Take a guess on how long that change took.
Several weeks.
It took 3.5 days.
Oh, huh.
3.5 days. Only because we had high performing servers and we got away with it. But what happens is, it's story time now, so I apologize for going on a tangent. When you make a major change like that to a database, it not only doubles in size initially, because you're constantly writing to the database, it actually triples in size because it has to take temp size. It has to get temporary file size to increase the size of the, and then they have to make a temp file to increase the size on the drive, and then write the actual file into the database. So you're looking, we went from using, I think that table was, it was like a 1.6 terabyte table because it was so badly designed. And by the time we were done, before we shrank it, it ended up somewhere like a 6-7 terabyte table, which is obnoxiously huge. For it's like having a dachshund that weighs 100 pounds. If you ever had a dachshund, you know that's a ridiculously sized dachshund. Anyway, I digress. I apologize for that. Hope that didn't confuse anybody. But so I owe you guys some in and any, some any and all queries, so you can run them against the Sakilla and see what they actually do. We're at time. Are there any questions, comments, concerns, thoughts about this week's work? Everyone good? Okay. If there are any, make sure you shoot an email to me. You guys have been great so far about asking me questions, and you can text me, email me, call me. If you call me, make sure you remember I'm in Eastern Standard Time, so I'm 2 hours. If you're in Utah, I'm 2 hours ahead of you. So it is 10:34 my time, and only 8:34. You're 3 hours, Aaron? Okay. You're in California?
Las Vegas.
Las Vegas? Ah, yeah. Wait, Las Vegas, oh, you don't have daylight savings time. Does Las Vegas use daylight savings time?
We do. We follow California.
Okay, so you follow California. Okay.
It's Arizona that runs. its own
Arizona,
little-
yeah. Arizona's its own little fiefdom. I don't know if you ever driven through Indiana. Indiana, based on the county, is whether they take daylight savings time. So it'll literally change as you drive through. I see Kate, you're nodding, so you know, you'll say like it's now this time, it's not, and you've got to back now with cell phones, it'll just change, and you'll just never know what time it is. I don't know how they do it. All right, if we're all good, let's call it a night. I'll get this generated out and I'll put it up by tomorrow morning. Okay. You guys take care. I'll talk to you next week.
Thank you.
Thank you.
Good. Thank
You're
you very
welcome.
much.
Thank you.